Okay, law of sines and law of cosines. I believe a lot of you did this in geometry last year. If you haven't, that's okay. But for some of you, it might be a review. This law of sines is 13.5, law of cosines is 13.6. So what we're looking at here is the law of sines is just the sine of an angle divided by the side opposite is equal to the sine of another angle over the side opposite. You don't need all three of them, you only need two. This is just showing that it works for every angle. And then the law of cosines, the important thing to remember here is that whatever side you start with, that angle is what you end with. Okay, so if I'm using angle A, I have to start my formula with the side opposite of it, and then it doesn't matter which one you call B and which one you call C on there. So those are just the three versions that mean the same thing of that formula. So example 1, we're using the law of sines to solve this triangle. So I have also solve the triangle means find all the missing sides and angles. So the first thing we need to do on this particular triangle, since we don't have any of the side opposite of the angle, we need to find what this angle is. So if we use the fact that a triangle is 180 degrees, if I do 180 minus 118 minus 22, this is a 40-degree angle. Now I can set up my law of sines. So I'm going to say sine of 40 over side opposite, 24, equals, and then I can pick one of the other ones. So let's start with this. This would be little b. So sine of 22 over little b. So now I'm going to cross multiply. So that and that. B times the sine of 40 equals 24 times the sine of 22. And then I'm going to divide both sides by the sine of 40. And I'm going to type that whole thing into the calculator all at one time to get the most accurate answer that I can. So let's see. 24. Also make sure you're in degree mode on your calculator. So I get, let's say 14. If we're going to round that even to the nearest tenth, we'd have 14.0. So there's my B value. So I found C, I found B. I need to find side C yet. So I can set up that proportion again. I usually always keep the one that I had to begin with. And now I'm going to say sine of 118 over C and do the same thing. It doesn't matter which, I could have used the B, my new B value that I found if you wanted to, instead of using the A values, whatever works for you. So divide both sides by sine of 40. So this is 33, we're going to say. 33 units there. Okay, so we found angle C, side B, and side C. That's what we were missing. All right, example B, or 1B. So I'm going to do law of sines again here. So I'm going to start with sine of A, which is 82, over side opposite, equals, and now I can pick one. If you want to do B or C, let's do B. So I'm going to say sine of B over 24. Same process, cross multiply. And now we got to get the B by itself. So sine of B is a whole thing. You can't divide by just sine and get B by itself. So we're going to divide both sides by the 29. So I'm going to have 24 sine 82 divided by 29. That equals the sine of B. And then just like we were practicing in the last section, we have to use the inverse to get the angle. Whenever you're looking for an angle, you have to use the inverse. So what I'm going to type in is going to be this whole thing, and I'm going to try to do it all at once so that I get the most accurate approximation as possible. So what that's going to look like, I'm going to do inverse sine, and then let's do 24 . Hopefully I typed that all in correctly. And we get an angle of, let's say, 56.7. Okay, so now from there, that was this angle. I only have one more thing I need to find. This one is easy. I'm just going to do 180 minus the 56.7 minus 82. This would be 41.3 degrees. So these were the two things I was missing on my triangle. All done. So law of cosines is a little bit trickier looking. So law of cosines, we can't use the law of sines on this because I don't have the side opposite of any of my angles. And we don't have a way to find that third side yet. So what I'm going to set up is, since this is the angle that I have, this is side C, so that's what's going to start my formula. So it's C squared, that's what I don't know, that's what I'm trying to find. And then it's A squared plus B squared, or whichever one of these you want to use first. So I'm just going to do 13 squared plus 29 squared. And the formula always has a minus 2 in it. Then I'm multiplying by the A and the B again. And then it's cosine of whatever angle you have. So in order to get C completely by itself, we have to do this whole string and then take the square root of it. So again, I'm going to do that all in one swoop here. I'll show you what that looks like on the calculator. Let me make sure I can see my problem and the calculator. Okay, there we go. So I'm going to do the square root because that's going to give me C by itself. And now I'm going to type all this stuff in just the way it looks. $29. So I get 21 here for the C value. So C is going to be about 21. Okay, now we use the law of cosines to find that side. We still have angle B and angle A. So since the law of sines is easier at this point, I'm going to use the law of sines now, because the law of cosines, we're going to look at that on part B. That's a little bit trickier when you have to find an angle. So I'm going to set up my law of sines. So the 41 is across from the 21 I just found, and then let's do angle A. So if I do my cross multiplying, sorry, I should have given you more space on this one. So I'm going to have to do, what's going to happen is I'm going to divide by 21 on both sides and then take the inverse sine of that. So it's going to become 29 sine 41 over 21. That's what A is going to be equal to. So we'll type that whole thing in. And I get 62.6. Did I type that in right? Hopefully I set that up right. That obviously doesn't look like a 62-degree angle. That's why I'm kind of pausing here. But the drawings lots of times are not to scale. So if I subtract these then, make sure I typed everything in right there. Oh, it was supposed to be 41. I don't know if that makes that much of a difference. Let's check and see. So I had 41. Checking my work. You guys know I make mistakes on this stuff. 29 times sine of 41. And then divided by 21. So 65 it gave me there. So we'll go with that. And then if I subtract them from 180, 180 minus 65 minus 41 is 74 degrees for angle B. Okay, one more here. So now we don't have any of the angles. So to find an angle, pick one, whichever one you want to start with. Let's do A here. So I'm going to start my formula with what's across from A. So it's going to be 14 squared equals, now the other two side lengths, minus 2, 9, 6, cosine A. All right, here we have to simplify piece by piece in order to get an accurate answer, because you can't just type this whole thing in at once, because we got to find A. So this is 196. I'm going to simplify that chunk right there. So that gives me 117. This whole thing is going to get multiplied. Now you can't subtract these. This is a common mistake. You cannot subtract these because this is being multiplied onto the cosine of A there. So this is just kind of like if you had 117 minus 2x, you couldn't combine those. So I have the 2 times 9 times 6 is 108. Okay, now I'm going to subtract 117 from both sides. That gives me 79 here. Okay, so now the next step is we're going to divide both sides by 108. So this is going to look like this, negative 108, sorry. And that's equal to the cosine of A. So to get angle A, remember whenever you're getting an angle, we have to use the inverse. So what I'm actually going to type in is this. So inverse cosine of 79 divided by negative 108, which gives me 137 for the degree measure there. So that's angle A. Now I can use the law of sines to find one of the other angles there. So let's do B. So if I say sine of B over 9, so this is I'm gonna divide both sides by 14 and then take the inverse sine. Gives me a B value of 26 degrees. And then if I do 180 minus 26 minus the 137, that means angle C is 17 degrees. So there we solved our triangle. Alright, so try the last two there. You might need to do some work on the back, I'm not sure, because obviously these took me a little bit of space. So, alright, have a wonderful rest of your day.